It's my real pleasure at this time to introduce Dr. Mark Finney. Mark is the senior scientist, one of the senior scientists at the Forest Lab, the U.S. Forest Service Fire Lab in Missoula. His topic is going to be the historical scope and scale of wildland fire in Montana, which is a big subject, covers a lot of areas, and so I'm really encouraged that Mark's agreed to do this for us, because I think we're all going to get a lot out of this. Mark has quite the background as far as ecological and other areas of study in fire. I know that he's been one of the primary movers of some of the modeling that's taken place in Montana by fire experts in determining the spread and intensity of some of the fires that we have, which has become more and more important to be able to model that sort of behavior ahead of time. And if you spent much time on the fire line, you know how important that is to have good predictions. He's also done a lot of research projects. Mark has his PhD from the University of California in Berkeley, a Master of Science in Fire Ecology from the University of Washington, and a Bachelor of Science in Forestry from Colorado State University. So please welcome Dr. Mark Finney.
Good morning, everyone. Let's do a little mic check here, make sure I have a lavalier on. We're good with that? Okay. Yeah, thanks, Ed, for inviting me and everyone for organizing this. It's a real pleasure to be able to be here in person. As most of you have experienced over the last couple of years, we've been meeting virtually, which is, virtually is good. I've been in COVID prison for a couple of years, and it's good to get out and mingle and talk with people. So I was asked today to provide some perspectives, historical and broad-scale perspectives on fire in Montana. I think that's a really important subject, and that's why I agreed to speak. Because every year we have fires, and we need to put those fires in context, the context of what's happening today, what's happened in the past that brings us to this point, and then what are our opportunities for the future. And so that's what I'm going to talk about. Montana doesn't get the headlines as much nationally, right? California is where most of the fire news happens, and for some good reason. There's a lot of people living there, and there's a lot of fire activity. California is the fire state, at least today. And so they've had record-breaking fires. 2020 was an extreme year, and it was predicted to get a lot worse, which in fact it did. Last year, the Dixie Fire was almost 1 million acres. Okay, we haven't had a 1 million acre fire here, single fire, for a long time. And so, but that doesn't mean we're not going to have them. So very similar kinds of things happening in California are also possible here in Montana. So the Dixie Fire was almost 500,000 acres, almost 1 million acres, which is unfathomable. Tremendous destruction to watersheds, habitat, timber supplies, pretty much every natural resource as well as community values there. But these kinds of extreme fires and record fires are happening all over the country. Colorado has experienced 3 record-breaking fires in one single year. The latest one was in 2020, where it was the Cameron Peak Fire, which is now the largest one, over 200,000 acres. And of course, we can't forget some of these fires are extremely destructive to communities, not just the natural resources, but you think about the Camp Fire in Paradise, California. It killed 84 people. Just went right through that town, obstructed the egress routes, and burned down the entire town, and killed 84 people. Now, if without perspective on wildland fire, you would think that this was unprecedented. But as this article from the San Jose Mercury News shows us, they look back in history and they said, this is very similar to something that's happened in the past. And they said a fire 100 years ago, 1918, that killed 453 people. So this is the important thing about perspective. Are these fires really the worst ever? Are they the worst that ever could be? Well, that's what we're going to do today, is we're going to look back in history and try to put all this in perspective. What these guys are talking about is the fire, the slide on the upper left, and that is the Cloquet fire in Minnesota. 1918 killed 453 people, was 200,000 acres. But there were lots of other settlement era disasters that I'm going to talk about, fire disasters, here in Montana as well. The Lake states, and before that, the Northeast up in Maine had these tremendous fires that were caused by settlement activities. They're associated with all the clearing and all the burning. Like the Hinckley fire there in the lower left, 1894, 200,000 acres, 418 fatalities. The Great Peshtigo fire, 1.2 million acres in Wisconsin, killed 2,500 people that they know about. Right? Our fires today don't sound all that bad. And then the great 1919 fire up in Saskatchewan and Alberta. There were lots of fires all over the West and the Midwest during this time. This one in Canada was 5 million acres, killed 87 people that they know of. So what I'm going to do today, this morning, is to cover a range in history. Not the entire range of all history, because I don't know that. I'm not a historian. But there's a number of different episodes in history with respect to fire that I want to talk about. Beginning with indigenous fire, okay? The people that lived here before us used fire an awful lot. Then settlement fire, as that occupancy of the land transitioned to the modern period. Then we are in this period I call fire control, or attempted fire control. And finally, in the later decades here, we've been in a situation officially known as fire management, which hopefully will progress and advance into the future, and I'll end with that. So instead of going through the normal timeline, starting at the earliest phase and going forward, I'm going to start now and go backward. That's really backward. So let's talk about the fire control period, right? Pretty much today is defined by attempts at fire suppression. And so we've created for ourselves a modern, what I call the modern fire regime. And that is we extinguish, or we attempt to extinguish all the fires. We succeed with only the mild and the moderate ones in all vegetation zones. And in so doing, what we're doing is we're storing the fuel on site for the worst case, for the 2% of the fires that we cannot contain every year. Every year. These statistics haven't changed in a century. Okay? We contain 98% of the fire, store the fuel, and then it all burns under the worst case. So the worst case is always dry, it's windy, it's spotting. Suppression forces are always overwhelmed. It doesn't matter how many air tankers or how many people on the ground, it overwhelms our ability to suppress fire. It creates large areas of high severity, and this is a very different fire regime than existed throughout the West, actually throughout the continent prior to the early part of the 19th century. If you compare what's understood to be the fire frequencies from before settlement with those of today, you can make a map like this. And what this is the ratio of today's burning rates, the modern burning rates of fires, compared to historical burning rates or prehistorical burning rates. And so everywhere that is in the cool colors, the greens and the blues, those are places that we're burning a lot less, 5 times less, 10 times less than historically occurred. 5 or 10 times less. Everywhere in the warm colors, the yellows and the reds, we're burning about 5 or 10 times more than historically occurred. So you can see that most of Montana is in the greens and blues. We're burning a heck of a lot less than we ever used to right now, except under extreme conditions. So before I talk more about that, I just want to show you why some places are burning more. And these are places if you look where they're primarily in the Great Basin. And the reason for that is invasive grasses. So we've got a lot of annual grasses that are invading what were desert sagebrush ecosystems, very dry and productivity limited, and the continuity of fuels historically was very low. And so it took very extreme conditions that didn't occur but once every century or so for fires to carry across that. But now what you've got is invasive grasses increasing the continuity of fine fuels, and the fires are able to carry every single year. And it kills off the sagebrush and a lot of other things too. It's not good for habitat. So that explains why some places are lit up in red and in yellow, right? Versus most of the forested areas are in greens and blues, burning a lot less. So let's dig in a little bit and look at some of this contrast in burning rates. This is an area around Missoula, but we could come up with an example like this for anywhere we wanted to. See that big black box there, okay? I don't know how big that area is, but it's pretty big. If you look at all the historical fires in there from 2000 through 2017, there are 5 big fire years, right? We know that not every year is a big fire year. Some years or fire years are episodic. Every few years you have one that really blows things out. So there are 5 big fire years, 2000, 03, 07, 2012, 2017. And that's where 97,000 acres per year about is burning within that big black box on average. So even with full suppression, it's not like we're not burning. We're burning 97,000 acres a year inside that big black box. As we window in a little bit in the red box, you can see we're burning about 8,800 acres a year, independent of everything we do, and always under the worst case. Okay, so let's dig in a little bit further on this. I'll be talking more about that red box, and we can come back to that slide. But within this area, if we look at the fire history, or the historical burning rates, they tend to array themselves by vegetation type, by elevation zones. And so at the lowest elevations, you have the most frequent fire, the shortest fire intervals, right? So you'll notice the ponderosa pine stratum there. It says about 10 to 30 years, historically speaking, was a fire return interval in those forest types. And as you go up in elevation and you change forest type, you end up and have longer and longer historical fire intervals. And what we can do is we can tally up inside any given area, but this is for the red box, right? You can tally up the number of acres inside that box, and you can divide the number of acres in each elevation zone by the fire interval, and you can get an estimate of how much historically used to burn, acres per year. And so inside that red box, I'll go back to it. Right now, we're burning 8,800 acres a year on average in wildfires. But historically speaking, inside that red box, we would be burning 36,000 acres a year. 36,000 acres a year is what would have been burning had historic or prehistoric fire regimes continued to this day. That's a lot more fire, right? So it's no wonder that vegetation has changed a lot in the last couple of centuries, and we'll talk more about vegetation change soon. So we can do these kind of comparisons everywhere. They're very useful for us to understand what's going on with our current fires relative to historic trends. So let's look at the fire record, the footprints of fires in the last 36 years. We can't go back farther than that with really good footprint information everywhere in the state. So that's why I just showed you the most modern period here, 84 through 2020. And so a lot of those, that's by decade there, and you can see that there's patches, a lot of blue in there and a lot of red in there, and that's from specific years where fires were much more active. But the state is actually burning at a considerable rate, even with all attempts to change that. We can look into the numbers a little bit. The numbers of fires haven't changed, right? Pretty much every year we have about the same number of fires. It goes up and down a little bit, but it hasn't changed all that much. What really has changed is the magnitude of these episodic years, right? We've talked about some of the years have a lot more fire than others, and look at the escalating sizes of these fires in the high-end years, right? Going all the way back, if you remember 1988, it's not on this graph, but 88 was considered a really big year. And not by today's standards, it isn't. 2017 broke all the records for burning in the state. So we can look at these fires just in the past couple of decades, and we can see some interesting trends in it. What these are called is a fire size distribution. It's the numbers of fires by size class. Okay? And if you plot them on log scales, you see a very regular pattern. You see that the numbers of fires, big fires, is a lot less than the number of small fires in almost a straight line fashion, right? You can see that I don't know if I can gesture with this. Will it show up? That doesn't really show up on there. But if you look at that, all the points are descending from the upper left. This is the percentage of fires by size class descending all the way down to the right, almost in a straight line fashion. And the reason for that is that the conditions that allow large fires and larger fires are a lot rarer than the conditions that allow small fires. That's kind of an immutable fact of nature here. This is not due to fire suppression. Okay, so what we have is most fire weather doesn't last long enough for fires to grow really big. bottom line. And you ever wonder where this 98% comes from? We're 98% successful at initial attack. Well, it comes from looking at the fire size distribution. If you pick a particular fire size and you say, okay, 300 acres, and that's the standard that's normally used, at least by the Forest Service, and you take all the fires or the percentage of fires less than 300 acres and you call that success, okay, that IA success is often defined as the percentage of fires less than 300 acres. So you see everything less than that vertical red line on there, that's 98% of the fires, okay? And so there's only 2% that actually get really, really large. And the reason that they get large has to do with how long they last and the extreme conditions that mean that they can't be put out. So this is the distribution of the percentage of fires by duration, how long they last. Most fires last, fewer than 10 days. Right? Most of them last only 1 day or 2 days, but then there's a few of them that last very, very long, into the hundreds of days. And part of this is a deception from the data. They don't really last 100 days, it's just that by the time they're discovered to the time they're declared contained is maybe 100 days. So we don't have real good numbers on exactly how long fires are active. But what you look at is for our 2% of the fires, 2% of the fires are greater, 60 days or greater. Right? That's a long time to have fire on the landscape burning under extreme conditions. And the reason that they're able to continue on like that is long duration of weather, but how they burn is actually a function of the fuels. It's a function of the fact that there aren't very many interruptions on the landscape that would change the behavior of those fires, right? If you look, I'll go all the way back here. Look at that. There's still a lot of room in Montana to burn without having one fire intersect another, right? So we don't have very many disruptions on the landscape to change that overall pattern. Okay, so big fire years. Big fire years. Well, this is 2017, and I can, could have dug up satellite images from all of the major years, 2003, 2007. But this is 2017, okay? Missoula and Helena are marked on the map. A lot of smoke being produced across the region, and so we're collecting smoke since the winds tend to go from the west to the east. We collect smoke from everything west of us and to the northwest of us, right? So we don't even have to have fires here in Montana to be breathing a lot of smoke. 1988, these episodic years have happened repeatedly in history, and I'm going back in time, so you're going to see some evidence of long ago fire episodes too. So you remember 1988, it was a big deal. Not so much right here in western Montana, but certainly in Yellowstone. But north of us a little bit, you can see that big line of smoke coming off right near the top edge. That is the Canyon Creek fire, all going at the same time. This is September 7th, 1988. And these fires, under those kinds of conditions, if there's live fire on the landscape late in the fall or in late summer, we tend to get very large runs. And so it's important when we're thinking about managing fires and managing fuels to think about it in this landscape context, as the governor said, right? This was the Red Bench fire going exactly the same time. This burned from across the North Fork of the Flathead River through Polebridge into Glacier National Park, 8 miles in 10 hours. The Canyon Creek fire, which we saw the image of, 27 miles in 12 hours. That's a long way away. And the reason this is important is that if you look to the west, 10 miles, 20 miles, those fires out there are your problem, potentially. Okay, we can't just be thinking about fire management in terms of where we are right here or what we can see. 10 or 20 miles off to the west is relevant to risk of fire anywhere on the landscape. You can see it right here. In 1967, a fire that was notable at the time for its size and its severity was the Sundance fire in northern Idaho. And this thing went 24 miles in 7 hours, spotting 10 to 12 miles. That's a long-range spotting. And you can see that very long cigar-shaped pattern in the red outlines there. 24 miles in 7 hours. That's quite something. So we're going back in time, remember, right? I'm progressing in reverse order here. So the Forest Service was formed in 1905. And many of the lands that had formerly been part of the Department of Interior were put in Department of Agriculture. The Forest Service is part of the Department of Agriculture. And the Forest Service, when it became into being, suddenly brought into effect what was called professional land management, professional forest management. And the principles from professional management, where did they come from? They didn't come from the United States. We hadn't been doing it that long. They came from Europe. They came from the wetter parts of Europe, from Germany, from France, and primarily where those principles were derived were for plantations. Okay, the old world, the continent of Europe, had been using and abusing its forests for a very long time, and they ran out of softwoods. And so they began, when they realized this, they began planting plantations and intensively managing them. And so that's where German forestry had its origin, in off-site plantations of softwood intensively managed. It wasn't necessarily developed for native forests that were fire dependent. Yet, when the Forest Service was formed, where did we get our expertise? We got that expertise from European forestry, right? All of our early foresters were trained in those principles, and we're still training in that today. But they applied it almost wholesale to the New World. When they came out west and they had all this public land to manage, they tried to enforce the same kind of discipline on our western fire-dependent forests as they did in Europe in plantations, which doesn't work out, right? We replaced with professional management what was the previous management regimen, and that was from Indian burning and settlement activities, which I'm going to talk about shortly, and then natural fires. The idea was to grow timber. It was not necessarily to manage in an ecologically sustainable fashion. It was to grow timber. That was the primary purpose at the time. And so fire suppression and control became incorporated into the land management efforts wholesale right after 1910, the great 1910 fires, but really was formalized in what was called the 10 a.m. policy in 1935. And that is where all resources are to be brought to bear to contain a fire by 10 a.m. the next day. And if you fail the next day, then you do the same thing over again, and you keep doing it over again until the fire's out. Okay, so this is no longer the policy. We have a different policy today, which I'm going to talk about at the end. But that was the policy up until 1977. Okay, it was about fire control. It was not about fire management. And yet, there have been a lot of fires, even with the attempt at fire control. Here's a map. It's an incomplete map, but it shows the fires from 1889 to 1984. So kind of up through the point where I had the previous map. And what you see there is, you see a number of very large blotches on the map, right? Big footprints of fires. There's big green ones and big red ones. And the red ones are from 1910, and the green ones are from 1889. And there's lots of other little ones. So let's talk about, we're going back in time. We're going to talk about the settlement fire era. Okay? The settlement fire era. And what I mean by settlement fire era is that we had an awful lot in those pictures there. You saw towns being built, wood products being needed. You saw horrifically large fires. That's Pulaski's Cave in the center. But we also saw a lot of mining. There was a lot of mining activity and use of fire to clear land so that they could be doing prospecting. Railroads were a major source of fires. So the settlement era was characterized pretty much by changes in land use. Cessation of Indian burning practices, which had been going on for millennia. Rapacious logging. It was uncontrolled, unregulated, unsupervised. There was just logging, exploitive logging everywhere, and slash burning. So there was no prohibitions on burning slash any time and every time during the year, and fires were present everywhere. This meant there was a lot of careless use of fire, right? Clearing, road building, mining in particular, agriculture, and railroads, major sources. So this is the settlement era. Probably culminated in 1910 fires. We're all aware of the 1910 fires and the importance to fire suppression policy by the federal government. But the 1910 fires burned about 3 million acres, multiple different it's not just one fire, it's many different fires, right on the Montana-Idaho divide, but also in the Rocky Mountains a little bit farther east, as you can see, all those black splotches there. So killed 86 people and transformed fire policy. But what's often not known about the 1910 fires is what caused them. And this wasn't just nature's revenge. This wasn't just some natural phenomenon that was going on. It was entirely related to the settlement era. This is a tally of the fire causes by Roscoe Haynes. He was a forest supervisor on the Coeur d'Alene National Forest at the time. And after the fires were done, you can see that locomotives caused 59% of all those fires. Lightning only caused 5% of them during that year. And all the other causes there that constitute minor fractions of those fires are human related. And now if you look at a map like this is a little different map, but 1910 fires, you see that the largest burned areas, the largest patches, are right over the newly created railroads. The Milwaukee Road, which went through Wallace, Idaho, was put in only in 1908. So there was still a lot of slash along the tracks, and they were burning wood in the engines, and the cinders would come out and they would light along the tracks. And normally the chase cars could put out all those fires, but in extreme years, with all that fuel, they couldn't get it all. And there are interesting articles talking about this, even in the New York Times. But the Northern Pacific Railroad also had the largest area of continuous burning because all of the fires were started along the tracks, right? That's the 1910 fire scenario. So we always think that today's smoke is just the worst ever. Everybody talks about how bad the smoke is. But there are interesting passages from the settlement era on smoke. These are some excerpts from the Missoulian, 1889, in Deer Lodge. Forest fires which fill the air with smoke are deplorable. They might have been expected in this dry year, so it's 1889, as combustible as tinder. The U.S. owns so much valuable timberlands in Montana and elsewhere, should make provisions for their protection. Many such fires might be stopped at the start if there were foresters of the right kind on hand. So you can see that people were getting sick of all these settlement era fires, not just from the destruction, but also from the smoke impacts to the communities. In Deer Lodge, again in July 28th, 1889, the forests are on fire, the valley is dense with smoke. It is no ordinary smoke, such as we have pretty much every year. So smoke was around all the time from all the burning. But it is a smoke you can taste, smell, feel, and almost handle. In Helena, I thought I'd put this one in because that's where we're at, but August 28th, 1889, heavy fires are raging in the vicinity of 10 Mile and are sweeping in the direction of Helena through Colorado Gulch, which is heavily timbered. It is feared several men were lost in one camp. So these fires have been big fires, disastrous fires, have been putting smoke in, terrorizing communities for a very long time. It is nothing new to us. So we're going back in time. So how much fire was there on the landscape during the settlement period? Well, one of the interesting sources is this map by Charles Sargent and others, who for the 1980 year census, 1880 census year, interestingly, they mapped the percentage of areas within these census units, census blocks, that had fire in them. And you can see that there's not much fire, all the shading on that map, not much fire in the West, but that's because there weren't very many people in 1880 in the West, right, for the census. It's not because there wasn't a lot of burning. But take a look in Montana, you'll see that in western Montana and out into central Montana, there was big areas that were noted with fire. And if you look at the key there, the legend, some of these places are 0.1 to 1% of those polygons had fire in them, just in that year. So that means that, if you add up, kept doing that every single year for a decade or two, there was a lot of fire. Certainly a lot of fire on the landscape. But look at the causes of the fires in 1880. Clearing land, 1,152 fires. Hunters, locomotives, malice, improving pasturage, right? Indians, you get all the way down there. Lightning is only a tiny fraction of the causes for these fires. So we can look to other sources of information for better descriptions, more detailed descriptions of what fires were doing to the land and how profound they were in changing the forest. Remember I said that the Forest Service was created in 1905. lands were transferred from the Department of Interior to the Forest Service. Well, before the Forest Service, the Department of Interior created what were called forest reserves. And these forest reserves were places where they didn't know really what was in it. The government didn't have a good inventory. So they sent people out on horseback to ride around and report. And they wrote reports on every single one of those places in green. So those are not national forests there, those are the forest reserves. And there's a report on each one. And when the people who were out there, they looked and they talked about this timber species, the amounts of timber, the mining, the logging, the settlement activities, all of that stuff. And they also reported on fires. Not all of them, it's not a formula, so every report's a little bit different. But you can see in the circle there that there's a number of places in Montana, and there's actually more there. There was more than is on that map in Montana. But let's just look at a couple of these. We don't have time to look at them all, but they're online. You can go read all this information and find all of this stuff I'm presenting here. This is from a map from Lieberg, 1899, his review of the Bitterroot Forest Reserve. So that map there is the Bitterroot Forest Reserve, and the Bitterroot Valley is that drainage, that river system on the very far right-hand side. But in the hatched areas, what those are is areas that had burned within the past century. So he did a pretty detailed job of mapping out areas. Look at all the fire that had burned within 100 years, more or less. He didn't know exactly the dates, but there was a huge amount. 1.1 million acres on this area with evidence of burning in the past century. So I just want to read a couple of passages from here. Most of the fires can be traced to Indian occupancy, appeared to have originated along lines of these trails. He was referring earlier to trails through the mountains, through the Loxa River and things like that. Almost the entire forest adjoining second growth in the areas known as the Bald Mountains, grassy southern slopes, long since deforested by fires, were also confined to the tracks traversed by these routes. So Indian burning was very common throughout the area, but primarily along the travel routes, and it manifested in changes, profound changes to the vegetation. You had grassy south-facing slopes without timber on it because of all the burning. The second passage there is, during the Indian occupancy, there were fire losses of 11,350 acres per year. That's his estimate, 11,000 acres per year. During the time that the white man has been in possession, 35,000 acres per year have been destroyed, or a yearly average 300% greater. So we're talking about the settlement era. Indians were burning, they were burning all the time, but during the settlement era, the rate of burning went up tremendously, 3 times according to his estimate, because of all the mining and the clearing. And a lot of them talk specifically about mining, because in order to look at the surface geology, they had to get rid of the vegetation. And so they were burning in a very wanton fashion. Yet, there were 200,000 acres or so. Oh, that's cut off, that's unfortunate. But there were 200,000 acres of what he called old growth yellow pine in the Bitterroot Forest Reserve. And so even with all this burning, and these stands were repeatedly burned. This is what the ponderosa pine forest looked like at the lower elevations, right, where most of us live. They didn't look like they do now. They were very open, large trees, grassy understories, very little fuel. Let's look at Ayer's report on what was called the Lewis and Clark Reserve, and this is pretty much the Rocky Mountain front. It covers the Bob Marshall, and so I know the graphics are fairly small, but the lower left-hand corner is Seeley Lake, and down in there, Augusta's over on the far right. And this goes all the way up to the edges of what's now Glacier National Park. That's the northern boundary here. So all of the hatched area, once again, was identified as being burned very recently. In this case, is 1.15 million acres burned in the last 40 years, primarily in the settlement period. So Ayer says, many of the eastern foothills, now grassed, proved upon close examination to have been once wooded, for here and there upon them old charred roots and stumps are found. And so I'll just read the next passage and then show you some pictures of it. The greater area, probably 1,200 square miles, was burned during 1889. This is the big 1889 fires that people were talking about in Deer Lodge and in Helena, right, choking them out with smoke. It was exceptionally dry. But at that same time, the Great Northern Railway was being built across the mountains, and the great number of men employed in its construction and the many prospectors and claim hunters attracted by the opening of the country made a combination of circumstances very favorable to the starting of fires. It's probably a kind way of putting it. So if you look at the old pictures, the repeat photography is fantastic here. It's something that we should really do a lot more of, because the landscapes change tremendously, and change not only from land use changes like, you know, agriculture and logging and things like that, but it's changed because we've been removing a lot of fire. But in the upper left-hand corner is a picture from Ayers, 1889. This is on the Sun River. 1981, George Gruhl did repeat photography from the same area, and you can see the increase in tree cover. And then I did a little Google Earth flyby, and the date of the image from approximately that area is 2014. And so the forests have come back a lot, right? A lot of these settlement era fires and Indian era fires pretty much removed the forest, except for small patches along the Rocky Mountain front. Tremendous changes. And yet, in places like the Swan Valley and the Seeley Lake area, we had larch, Doug fir, and ponderosa pine forests that were very open. They were kept open by this frequent burning. You can see these stands from 1889. Ayers talked a little bit more about things, which I think is kind of interesting. The causes of these fires may be grouped into 4 classes. First, those originated or indirectly from the railroad. Right? He mentions railroads right away. Those running from the prairie. Third, those escaping from settlers on the borders of the forest. Fourth, those caused by Indians, hunters, and prospectors. And so what he's talking about here is just the settlement era causes of fires, of all this burning. There is no doubt that some of the fires, especially on the higher ranges, are due to lightning. But most of those in the valley seem to have been from Indians and other hunting parties or by prospectors. Let's look at the Flathead Forest Reserves. This is just north of, this is what's Glacier Park now, and a little bit farther to the west, almost to Eureka and north of Kalispell. All the places there in the red that you're seeing, those are areas that are severely burned, where the forest has been removed by recent fires, just in the settlement period. And so one of the passages here on that Flathead report is that evidence of severe and repeated fires, this is the North Fork of the Flathead, evidence of severe and repeated fires is abundant. Actual prairie making has been accomplished. So fires were so frequent in the North Fork that forest couldn't grow. That every time seedlings would get started in these meadows, they were burned off by Indians earlier and then by settlers. And if you've been up to the North Fork of the Flathead by Polebridge, you'll notice that there's interesting relictual stands of ponderosa pine, even in that fairly wet area. And those were maintained very likely because of these frequent fires. They wouldn't be there under a fire regime that's more typical of lodgepole pine, which would replace it if humans hadn't been burning. So here's just another passage from Columbia Falls. Fires have scorched and lightly injured butts of large trees, and occasionally blackened stubs are found. Here and there are areas of several acres on which small trees up to 2 inches in diameter, 2 inches, have been killed by these light fires. So they were pretty light fires if he's worried about 2-inch diameter trees. Okay, and so lots of pictures in these reports of these open stands that were underburned. At the higher elevations on the steeper slopes, that's where the fires were more severe, and there was lots of open places. And we can see all that from these repeat photography studies. And so the one on the left is by George Gruhl. He did a lot of work in Montana in the Northern Rockies area with this, but there's also other pictorial sequences that really show this change. I'll just show you a few pictures. So the one on the left is 1906, 1908, somewhere in there. They don't know the exact date, but look at the open hillside. This is a north-facing slope, but look at the open hillside there in the background, and that's all filled in by 1981. This is why we really need to go find these photo points again and take these pictures after, another 40 years. I think it would be really interesting. Some of these places would have burned again. This is up by Glacier National Park, Columbia Mountain, Tea Kettle Mountain. You can see on the image on the left, the open forest, the open bare hillsides, the open valley bottoms compared to the image on the right, where pretty much continuous forest is recovered. Crown Mountain, the same thing. The foreground is entirely denuded. There's lots of stumps and snags in that area compared to today that's clothed pretty much entirely in Douglas fir. This is not just a forest issue, the forest change that's occurred widely across rangelands where brush and juniper has encroached in a lot of these areas. Here's a picture also from George Gruhl showing the changes just in about 80 or 90 years. So we're going back in time. We're going back to I've alluded to this many times, a lot of the passages from the settlement era and those observers talked about Indian fires. So this indigenous burning period went back millennia. I don't know how far, but at least 10,000 years since the ice sheets withdrew. People have been here and they've been manipulating the land. Fire was one of the main tools. And unlike us today, modern humans here, they did not have the technology nor presumed to have the technology to stop fires. They didn't try, and they used it extensively. So we know that from lots of different anthropological and ethnographical kinds of sources. These are two very good books, should you like to read up on these. The one on the left is Forgotten Fires, Native Americans and the Transient Wilderness. They call it a transient wilderness because it wasn't really a wilderness. People were there and they were manipulating, they were managing, they were doing a lot of things out there. It wasn't just a vast open area without people. And both, the one on the right is the biggest estate on earth, and this talks about Australia. Australia is very much in the same situation as we are here. Aboriginals there had been occupying and burning that area for 50,000 years. So both of these books document a couple of important points on the left. Fire deliberately used by indigenous people, very sophisticated uses. Regularly and skillfully burned virtually the entire continents. Okay? Doesn't matter which end, wet places, dry places, hot places and cold places. Indians used fire all the time. Humans were very much a part of those wilderness areas. And so at the time of European contact, the landscape was certainly not a wilderness. It was in a manipulated condition. And so when you looked at the forest, the extent of it, the species composition, the size of those trees, and all of those characteristics, they were a product of the previous managers of the land. A number of different sources, other sources, I just picked this one out. This is again by George Gruhl. He was a research scientist with the Missoula Fire Lab before my time. But here he went and looked at a bunch of written sources on pre-settlement fires. And Fire on the Western Landscape, he called a record of wildland fires 1776 to 1900. And you can see the broad area that he covered in terms of finding written sources that had eyewitness accounts of fire. Not just active fire, but fire activity on the land. And I'll just read a few passages. Indians were identified as the primary ignition source over wide areas at lower and middle elevations. 41% of all the observations he had. And so there were a lot of other causes, but none of them constituted as large a fraction as the indigenous burning did. Extensive fires swept through the grasslands every year during the period 1832 to 1877 at various locations in central and eastern Montana. So the prairies, the eastern part of Montana was covered by fire almost every single year, by either accidental fires or by intentional burning for driving buffalo. And it led to this kind of provocative title by Charles Kay, professor in Utah, Are lightning fires unnatural? Most of us would say, well, lightning fires are natural, but if there was so much burning that was going on through human agencies, then lightning fires would have certainly been a much smaller proportion of it, and perhaps the kind of lightning fires that we see now, episodes of lightning and lightning-caused fires for these under extreme conditions, maybe that would have been historically much rarer. So what's interesting, I just found this report. I thought it was interesting to talk about. There's not that much information about actual indigenous burning practices through ancient history, right? There's some oral tradition but a lot of that covers only the recent generations. It doesn't go way, way back in time. But what this is a report on was burning activities associated with buffalo jumps on the Blackfeet Reservation. So the buffalo jumps were an important way that they could get a lot of meat, right? And what it is there's a cliff, and they would have these drive lanes the Blackfeet Indians would have these drive lanes, which were cairns, rock cairns and full of brush and sticks, and they would drive the animals into these drive lanes, and that funneled at a tighter focus, funneled the animals towards this cliff, and then at the last minute would charge them off the cliff, and then they'd be able to kill them at the bottom. But what's interesting is that there are sediments associated with these drainages near these buffalo jumps that record the deposition of sediments, but also charcoal. And if you look at the charcoal lenses within all these sediments, you can get a proxy for the amount of fire activity that was going on the land. And so look at that colored graph there with the red on it. That's the amount of charcoal over time. So you're seeing this timeline goes from 1000 AD all the way up to 2000. About at present. And all those red lines, the red graphs, that shows the amount of charcoal deposition and thus the amount of fire activity that was going on. And it pretty much ceases about 1650. Well, that's when the horses were introduced from the Spanish, escaped from the Spanish. And so the Indians no longer had to hunt buffalo on foot using fire. They had horses to help do their work. And so the important point of this graph is just that Indian uses of fire changed over time in ways that we have no idea. But they were very proficient with its use. They used it a tremendous amount, as is indicated here. So I'm going to wrap up with talking about the future and the future of fire management. Now we have some perspective on Indian fires and settlement era fires and modern attempts at fire suppression, right? We can understand a little bit about when we have fires every year, how are those sitting on our landscapes over this long timeline of changes? So let's talk about what our future is, right? And that's entirely up to us, what we choose to do. And whether we choose to proactively manage fire or pretty much resign ourselves to being victims of it. What we really need to do is establish objectives, management objectives for fire, which we have not done, right? All of the other kind of land management goals that we have, whether it's timber or recreation or grazing, watershed values, we have objectives, measurable objectives for that. But what are our objectives for fire? Usually we don't have any. It may be tacitly assumed that we're going to keep fire out, but as we've shown, we can't keep fire out, no matter how much we've worked, how much money we spend. So what are our objectives for fire? Is it to only have the worst ones, right? Try to put them out under all conditions we can and accept the 2% losses of only the worst case? Is that our objective? Well, that's not really sustainable for a lot of our ecosystems, is it? It's not really the best way. It doesn't follow the ecology, the science of how to sustain fire-dependent ecosystems, right? It's not compatible with our current occupancy on the land, our communities, and our needs for natural resources, right? And in a lot of cases, it isn't even desirable. So I think what we need to do is collectively as a society figure out what are our objectives that are sustainable for these ecosystems and our uses and our presence, and what do we want? Now this kind of thing is not new. These kind of questions are not new. In the 1970s, the changes in the vegetation and fuels that were happening were noticeable. They were noticeable far earlier than that, but I don't have time to detail all of that for you. But this was a paper written in 1971 by some Forest Service researchers where they talked about the fuel buildup in American forests, and they needed a plan of action to move forward. 1971, it's a long time ago, and the fire problems weren't nearly as severe, but yet they were anticipating much worse conditions. And here they identified a number of research needs and actions to take. One is increasing greatly the amount of prescribed fire. Mechanical fuel treatment is another one. And then the third one I think is super important. It's something we haven't done at all, and that is communication with the public. The public must be made aware of the conflagration potential for forest fuels buildup, the need for treatment measures or to reduce or eliminate this hazard, and the role of prescribed fire as an ecological tool. That sounds like something the governor would have just said this morning in 1971, and we're still not doing it. Right? We're still really not embracing what we knew to be necessary in 1971 and much, much earlier. Well, the Forest Service, realizing in the late 1970s that we were not getting ahead, of the fire problem. They took a hard look at the data. They knew that the more money we spent, the bigger the fires got. And it wasn't that we could spend our way out of the problem. And so they say here that the Forest Service built a high-cost, technically sound fire organization, which is true, but alarming trends in the 1970s, more fires, more area burned was happening, it was more costly. So the policy changed from the 10 a.m. policy in 1935. They changed the policy in 1977. And we are, as Thomas Nelson wrote here in the Journal of Forestry in 1978, we are in a new era for the National Forests. At least he thought so, for fire management. Now, Thomas Nelson was the Deputy Chief of National Forest Systems, so in charge of management of the National Forest. And if he thought that we were in a new era, we would be incorporating fire management into land management at that time. That was the direction, which is a good direction, and we still haven't done it, right? The heart of the new policy is the integration of protection and suppression into the land management planning process. It should be noted that in some places, particularly the southeast, the Forest Service had recognized this concept much earlier. In the southeast, they prescribe burn about 3 times more land than they burn in wildfires every year. In the west, we burn about 12 times more wildfire than prescribed burning. So how can we have one country and 2 different systems? That doesn't make a lot of sense. All of this information about proactively managing fire has been recapitulated and emphasized and supported by every major policy document that's come out since 1978. I just have a few here. The Federal Fire Policy, revised in 1995 and 01, policy guidance clarified in 2009, and then the Cohesive Strategy all calls for fire resilient landscapes, fire adapted communities, right? So how do we do that? Well, through science, that's probably the best way. That's certainly the approach that I would advocate, and we have a lot of science. We have a tremendous amount of science over the past century. Really, it's been going on a long time of how to manage fire and how to manage our forests in fire-dependent ecosystems. And there's a lot of literature. There's probably 300 or more publications on this, and I'm going to start number 1 and go all the way through, okay? So sit tight. Actually, I'm just going to summarize this. If you distill all that literature down to just what are the main points that unanimously pretty much have been concluded, they would be this, is that fire itself is an irreplaceable factor in managing fire-dependent ecosystems, whether it's prescribed fire or whether it's wildfire. Doesn't really matter, but fire is irreplaceable. You're not going to be able to mechanically duplicate the effects of fire. Why? Because fire removes surface fuels, right? That's not merchantable stuff. We're not going to go rake the forest. It's too much of it, right? So wildfire removes surface fuels. It removes litter and duff. Litter and duff, what most people don't understand is that constitutes the vast majority of the fuel loading in all of our forested ecosystems, right? We may have 40 tons per acre of litter and duff out there, and yet only 5 tons an acre of woody fuels, okay? And litter and duff is continuous, it's very long burning, which matters a lot to how deep our flame zones are in the fire effects, the physical processes that go on in fires. Okay, rotten wood. Why is rotten wood important? Well, that's what catches all the embers. That's what allows fires to spot 10 or 12 miles like we talked about, right? If you've ever walked out in front of wildfires and you've seen where the embers are lighting, well, it's in little pockets of rotten wood, and that's not because embers are very smart, okay? It's not because they seek out those places. There are so many embers, they're like raindrops. There's so many that it's impossible to count, okay? But the only ones that actually light are the ones on rotten wood. Well, how are you gonna get rid of rotten wood without burning? Kill young and small trees, right? To keep these forests open, like we saw in all those old photographs. Fire sweeps through the forest, removes reproduction, keeps the understory open. Scorch and kill the lower limbs, right? So you can limit up, increase the distance between the crown and the surface to keep crown fire out. Top kill brush species. How are you going to keep knocking those things back in the understory? Well, fire is irreplaceable. And so the conclusion from all of these hundreds of studies, pretty much the synthesis of all of that information, is that logging and thinning and mechanical activity may be necessary for managing the fuel and the fire hazard in our forest. It may be necessary, but alone it's not sufficient. What mechanical activities mainly do, okay, is they restore structure, or they change structure. And they do it in a very reliable way, in a predictable way. And that's good. Fire would, if you just used fire, that would be far more risky and far less certain. But mechanical activities only remove the stuff that can be removed mechanically. It doesn't remove all the other fuels that I just talked about, right? And that's the stuff that actually makes future wildfires behave the way they do. So we have lots and lots of evidence of this, and we shouldn't be ignoring it. We shouldn't be advocating just logging our way out of the problem, because we've proven we can't. We can't fight our way out of the problem, right? And we can't log our way out of the problem. But one way or another, we will burn our way out, right? Whether it's prescribed fire or whether it's with wildfire. So look here, the litter and duff. Most of us don't think that litter and duff is too much of a fuel hazard, but look at this forest. This is in Colorado. I don't have a Montana example, but these firefighters were here protecting this important structure on the left, and as the fire came over the hill. But in the foreground, you see on the ground, there's only litter. There's only pine litter. There's no dead and down woody material. There's no brush. There's no dead trees. There's nothing. But watch the fire come over the hill. And it pretty much, it destroyed the entire stand. It was a crown fire. Why? Because this fuel burns for a long time. Under dry conditions, it'll burn for 10 minutes, flaming. Okay, and so if the fire is moving very fast and it stays burning for 10 minutes, you have very, very deep flame zones. Not just a thin little flame zone that goes through, that mixes a cold air in there, but very deep flame zones that are able to take the entire stand out. So let's look at some other examples. We have lots of examples in Montana where areas have been harvested and then encountered wildfire. This is from the Chippy Creek fire as it came into the Flathead Reservation in 2007. And you can see this intermix of different cut units there. Made no difference. The fire went all the way down to the grass. The Rice Ridge fire in 2017. We see here the early phases of it. Burned across checkerboard lands, right? You know, checkerboard, every other section is owned by industry and then public land. And if 50% of the landscape in a harvested, clear-cut condition doesn't change fire behavior, then no amount of cutting is going to change fire behavior. And so you can see here in the center part there, it burned right through checkerboard as if it wasn't there. Not too far from Missoula, we had well, actually, this is a different example. This is up by Kalispell on the Flathead. But we have 3 different fires that burned together over a series of years across a matrix of different kinds of cut units. And none of those cut units mattered much to the growth of the fire or to the behavior of the fire. But what you can see there is the Little Wolf fire at the very bottom burned in 1994. And then Elk Mountain fire, number 2 there at the very top, burned. And then number 3 was the Brush Creek fire in 2007. And the important thing is it burned across this matrix of different cut units, but the only places it actually held up are places where it intersected previously burned areas. It's the absence of surface fuel and absence of fuels that other fires have consumed that really changes the behavior. So one last example for you, and this comes from Arizona, but it's probably the most dramatic example that I know of. The Rodeo Chetasky fires burned together in 2002. They were the largest fires at one time in Arizona history, 463,000 acres in one burned area, which is really, really big. But if you look, this is a satellite image, Landsat 7, that took pictures of these fires spreading. And a couple of really interesting characteristics of these fires popped out at me as I saw it. The one on the left there, the fire is flat at the front. Fires don't spread that way. They spread with more of a point, more of a rounded oval point. But in the one on the right, it has a bunch of big holes in it. Right? You can see there's a big hole there, and on the right-hand side, there's a kind of an angular edge to it. That's not the way fire spread. This is very odd to me. And upon inspection, we found out that the reason for those holes and those strange shapes of those fires was because of prescribed burn units done within 10 years before that fire. And so these are big units, right? Collectively, these 2 fires, and I'll show you in just a second, burned total 463,000 acres. Those individual prescribed burn units are 4,000 to 5,000 acres each. That's pretty big. And so when I asked the Bureau of Indian Affairs, this is on the White Mountain Apache Reservation, I said, how did you guys burn that? Was it aerial ignition? Because I couldn't imagine them carrying that much torch fuel and doing that. And they said, no, we burned with matches. And so I pressed him, I said, what do you mean burned with matches? Well, we basically just got a lot of boxes of Strike Anywhere matches, and we went and we just flicked them into little jackpots, and they all kind of merged together and eventually burned the area. So this prescribed burning does not take highly sophisticated techniques, okay? It takes willpower more than anything else. And if you look at the post-fire image of this, you can see that this is the combined area. This is the fire severity map. The only places that are green in the entire area are places that had previously prescribed burn, even though everything inside that big black circle was commercial forest. It was designated commercial forest. It had all been harvested and all been thinned and all been cared for mechanically for a century, because they were feeding their mills, right? Not only on the Mogollon Rim on the Forest Service side, but also on the White Mountain Apache. So none of that made any difference except for where they had prescribed burn within 10 years before. And that's what it looks like. Both areas have burned, by the way. The one on the left burned too. Just didn't burn severely, right? Because there was not much fuel in there. So it's not about how much fire we have, it's about what the fires do. So my last slide is the only real choices we have in wildland fire are when do we want it and what kind do we want. We do not have the power to choose not to have fire, right? Those are the choices. So if these are the choices, and all of the science and all of the experience says they are, then why wouldn't we choose to have fire that sustains our forest rather than destroys it? Thank you.